Alright, so in school, we're always told this one rule about right triangles. The square of the hypotenuse is equal to the sum of the squares of the two other sides. And in math, we call that a squared plus b squared equals to c squared. And we're just supposed to accept this? Where does it come from? And why is this true? Why shouldn't we just believe it just because we got it out of a textbook? Let's find this out by proving it. And we're going to be using nothing less and nothing more but triangles and a little bit of creativity. Now, let's draw one right triangle, and we'll call it the corners A, B, and C. Let's say the right angle is at A. Now let's label the sides. AB equals to B, and AC equals to A. And the hypotenuse, the longest side, BC, equals to C. Now here's a thought. Why stick with only one triangle? If one triangle is good enough, maybe more triangles would be better, right? So let's duplicate it 4 times to see what we can do with them. Now, let's play around with these 4 triangles. What if we were to arrange them into a square-like shape, but with the hypotenuses all pointing inward, forming a tilted square in the middle? Yeah, and just like that, the legs A and B form the edges of a bigger square, and the 4 C sides form a small square in the center. Nice! We've just built a square made out of 4 right triangles and a smaller square in the middle. Now, let's look at the outer square that we just made. Each side of it is made of one length A and one length B. So the full side is A plus B. And the area of any square is just side times side, right? So area equals to A plus B times A plus B, so A plus B squared. That's our first expression. Let's keep it in our pocket for now. Now, let's look inside the big square and add up what it's made of. Inside, we've got 4 identical triangles and 1 little square in the middle, made from the C sides. Let's do the triangles first. Each triangle has an area of height times base divided by 2. So putting in our variables, we have 1/2 of AB. And since we got 4 of them, that gives us 4 times 1/2 of AB equals to 2AB. Now, the square in the center has side C, so its area is simply C squared. So the total area is 2AB plus C squared. Now, here comes the magical moment. We got 2 different ways to describe the exact same area. So let's set them equal through an equation. A plus B squared equals to 2AB plus C squared. And now let's open up that left side. What's A plus B squared? It's just A squared plus 2AB plus B squared. And now we can write A squared plus 2AB plus B squared equals to 2AB plus C squared. Okay, we got 2AB on both sides. Let's cancel them out. And what's left? A squared plus B squared equals to C squared. And boom, that's it. That's the Pythagorean Theorem. We didn't guess it, we didn't memorize it, we built it, step by step, using logic and clever arranging. Okay, so now that you know exactly what to do with the Pythagorean Theorem, let's give you a problem. A ladder is leaning against the wall. The bottom of the ladder is 6 feet away from the wall, and the top of the ladder reaches 8 feet up the wall. Now, how long is the ladder? We're looking at a right triangle here. One leg along the ground, 6 feet, and the other leg up the wall, 8 feet. And the hypotenuse, the ladder, well, we don't really know this one yet, and that's up to you to solve. Pause the video and try to solve it for yourself. After you've taken your time to solve this problem, let's try to solve it together, once and for all. So here in our problem, we recognize that there is a right triangle. And to find the hypotenuse of a right triangle, we can use the Pythagorean Theorem, or to remind you, A squared plus B squared equals to C squared. And by crunching our numbers into the system, we get the following equation. 6 squared plus 8 squared equals to c squared, or 36 plus 64 equals to c squared, and finally we get 100 equals to c squared. And when we run this into a square root, we get c squared equals to 10. And so, in conclusion, our ladder is 10 feet tall.